Hi, I'm JD, and what we're going to be doing today is a multinomial distribution. Let me read the problem. A candy company produces candy in a variety of colors. They found the percentages produced are 12% brown, 15% red, 12% purple, 20% blue, 12% yellow, 15% green, and 14% orange. In a random sample of 14 candies, what is the probability of getting 2 of each color? So pause the video and try to do this one on your own. Alright, notice a couple things. Well, first off, you have different probabilities, right? It's not a binomial distribution because you don't have this or this. You have this, this, or this. On top of that, all of these percentages should add up to 100%, which they do because I checked earlier. So you have to find the probability. So you're going to use the formula for a multinomial distribution. So the formula to find the probability is P of x equals n factorial over the number of successes. And you're going to split them up into categories. So you have brown, red, purple, blue, yellow, green, orange. So it's 1, 2, 3, 4, 5, 6, 7. So you're going to need 7 of these. x1 factorial, x2 factorial, x3 factorial, x4 factorial, x5 factorial, x6 factorial, x7 factorial. Times the probability of success for each category. So it would be P1, and that's going to be raised to the number of successes for that category. So it would be P1 raised to the x1, P2 raised to the x2, P3 raised to the x3, P4 raised to the x4, P5 raised to the x5, P6 raised to the x6, P7 raised to the x7. So that's your formula, and it's going to vary depending upon the number of categories. If I had more categories, I would have more of these. Now, the N stands for the number of trials. Here, the number of trials is 14. So P of x equals 14 factorial. Now, underneath the number of successes, I want 2 of each category. Well, 2 of each category would be, or each color would be 2. So it would be 2 factorial, 2 factorial, 2 factorial, 2 factorial. I need 7 of these. 1, 2, 3, 4, 5, 6, 7. It's a lot of 2's. Now, to do this part, you have the probability of success. Now, 1 for each category. So you're going to have brown. And make sure you convert the percentage to a decimal. So it would be 0.12 raised to the second power. Now I have red, which is 0.15, and I'm selecting 2 where I want to from that category, times 0.12 raised to the second power times 0.20, or just 0.2, raised to the second power times, now that was blue, and now I have yellow, 0.12 raised to the second power. Then I have green, 0.15 raised to the second power. And then I have orange, 0.14, because that's the probability of success in that category, raised to 2, because that's the number of ones that I want. All right. So to calculate this, you want to be careful when you're typing it into your calculator. Now, typically, defined factorial is going to be under where the probabilities are, the combinations or permutations. They're going to be in the same location. So first start by typing in 14. Type in 14 factorial divided by, and I'm going to put all of this in parentheses. So 2 factorial. Now 2 factorial is just 2 times 2. So, or sorry, 2 times 1. So this would just be 2 times 2 times 2 times 2 times 2 times 2 times 2. So let me do that. 2 times 2 times 2 times 2 times another 2 times 2 times 2. There should be 7 of those. I'm just going to double check. 1, 2, 3, 4, 5, 6, 7. Close parentheses. Now I'm going to type this in. So times 0.12, and I can just square it, times 0.15 squared times 0.12 squared times 0.2 squared times 1.2 squared times 1.5 squared times times 0.14 squared. Now let me read it back, because I think I was mispronouncing some of them. So from this part on, 0.12 squared, got it, times 0.15 squared, got it, 0.12 squared, got it, 0.2 squared, got it, times 0.12 squared, got it, times 0.15 squared, got it, times 0.14 squared. Enter, and it's approximately, I'm going to round to 3 decimal places, but I actually might use 4. So I'm just going to use 4 decimal places because it's very small. It's 0.0008. That's it.